Tell me.
Yeah, so actually, before starting with the session, myself, I was having few doubts. Like you must be knowing regarding that we were our university was participating in the Baha season for the 2022. So that
Mm-hmm.
his season has been completed, and I wanted to talk you regarding the steering system of that particular vehicle. Even in the design phase, we asked a lot of doubts with you.
Mm-hmm. Mm-hmm.
So
Correct,
now
correct.
what happened is, like now we are shifting to four-wheel, right? So we
Okay,
are really
Shubham,
confused that.
actually, yeah, actually, I will hold a doubt session for vehicle dynamics course students in
Okay.
this week and also in the coming week. So
Okay.
it will be better if we ask a doubt there because I'm pretty sure if we talk about Bahar and this kind of vehicle, it will take at least half an hour or 1 hour. So
Right,
it will be
right,
better
right, right.
if we take it to that session.
Sure, sure, sure. When it will be going to hell?
You will be informed on the Telegram group that you might be added to.
Sure, 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 sure. Okay, sir.
All right. Okay, I guess we can start. So hello everyone, my name is Arbaz, and as I can confirm from Shubham, I might be audible to you guys. Just to be sure, could someone once confirm if I'm audible to you guys?
Yes, sir. Yes, you are.
Thank you, Ayush. Sorry. Thank you, Rohan. Okay, so today with us we have Dr. Priya Jagtab from the Training and Placement Department of Sharad Chandra Pawar College of Engineering and Technology. I'm very happy to announce our association for this bootcamp. On behalf of ETG, I happily welcome you on board, and we appreciate mentors like you who take initiatives in guiding and making students industry ready. We also have students joining from Sharad Chandra College of Engineering and Technology from second, third, and fourth year, Mechanical and Electrical Department. Also, along with Dr. Priya Jagtap, we have Professor Garge Mayur and Professor Pawar Akash with us from the Mechanical Department. And before we start, I would request Dr. Priya Jagtap, ma'am, to say a few words to motivate our students before we go ahead. So, Dr. Priya Jagtap, madam, over to you.
Good evening, Arba. Thank you so much. Thank you for this opportunity. And, although I'm a non-technical person, somebody who's been following Michael Schumacher for years to an end, having an event, to do with Mercedes is like a dream come true. And because everyone is patiently, eagerly awaiting to hear you, I am not going to hold you a lot. I'm just going to quote Michael Schumacher, and then we will begin. When you start out in a team, he says you have to get the teamwork going, and then you get something back. So I believe this is us being part of a team, and with due respect to Michael Schumacher, who is, the icon for all of us. And every time we think of Mercedes, we cannot go ahead without thinking of Michael Schumacher. And
True, true.
I really appreciate this boot camp that you all have planned. And I'm more than certain our students will benefit, definitely, certainly, in the long run from this association. Thank you to your team. And over to you, Arbaz.
Yeah, thank you, Jagta ma'am.
Thank
That
you.
was really inspiring, really great. Quoting Michael Schumacher is the cherry on the top of the cake that the webinar that we'll be having today. So yeah, so like before we start, I just want to understand, students, do you know what exactly Mercedes is doing with their DES system before we actually go ahead? I have we have students here from I guess from our course. Ayush is here, Shubham is here, the ones who I recognize. I think you guys might be already aware of these things as we've had this kind of sessions before. But from college, this from the Sarah Chandra College of Engineering and Technology, is there any students who would like to give me an insight of what they know as to what exactly this DIS system is? So anybody, somebody has raised a hand. So let me just start out by saying that in our sessions, in Elite Techno Group sessions, you don't need to raise your hands. You can simply unmute yourself and have a conversation with us. So anybody who would like to give me a brief as to what they understand DS system is?
Sir, can I?
Sure, sure, sure. You go ahead.
So like sir, it's a dual steering. It's there's a butterfly joint. So
Mm-hmm.
when the driver has to take a turn, it usually press the steering and turn it. So it produces a negative camber that increases the traction for the on the road for the vehicle and takes a quick turn, like
Okay.
like better than any other vehicle. So I think like sir, the Formula Formula Association has banned it. Like it's not
Yeah, FI has banned it
legal for them.
recently. Correct.
Yeah.
Uh, Not the most accurate definition, Ayush, but I think we are headed towards the right direction. Shavin is here is saying that aligning the front wheel using push or pull of steering. Okay, so this is something you might have seen. In Mercedes last year's practice ranges, Hamilton actually did this. He pulled and pushed a steering wheel, and that actually changed the toe of the vehicle that he was driving. Right. So today we'll be going through what exactly happens while he changes the toe, why toe is necessary, right? First of all, we'll understand what is toe. Then we'll go to why toe is necessary in any kind of steering system, and how a Mercedes used DS system to take advantage of toe to change rather in their racing system. Okay, so I hope you all are very excited for that, and with that spirit, I would like to start. So I'll just share my screen. If somebody could confirm if my screen is visible, that would be great.
Yes, sir.
Sorry. Thank you, Ayush. And others from Sharat Chandra College Engineer of Technologies. Uh, uh, Apart from Ayush and Shubham, you guys are also welcome to unmute yourself and have a conversation with me. I do appreciate students' communication. I do appreciate the two-way learning and two-way teaching that could be done in this kind of boot camps. So for everybody who hasn't talked yet, this is your time to shine. Every time I ask a question, every time we have a discussion, feel free to unmute yourself and talk to me.
Yeah, so the DAS system is actually the dual axis steering system which enables the driver to push their toe in or pull the toe out in an F1
Correct.
car. So what it does is it helps in changing the sensitivity of the steering as well as you can warm up the tires. We have seen that on many instances when the safety car is out, the
Mhm.
Mercedes driver are you very seen on the camera trying to change their axis of the steering, and it helps them warm up the tire more than the other drivers could with the normal axis of the steering. So that what enables them with this change of the axis of the toe.
Nice, nice. So Ayush, that is something that I wanted to talk about. So I'm little, angry that you took that away from me. But anyway, in good spirit, I understand that you have pretty good knowledge, and I'd like to, polish that a little bit. What exactly they do with the toe change? Okay. So for everybody, now I'll be sharing my screen and my presentation. So we'll be taking a deep dive into toe, and we'll see how Formula One cars are adjusted for corners and toes, corners and states. I'm sorry, and then we'll get into what exactly Mercedes has done with TS. Okay, so to start with, what is a toe, right? So this is the top view of the car, and as you can see, there are three different conditions. Okay, and the first condition on the left side of the screen, as you can see, has no toe. So if you're seeing the car from the top view, toe is nothing but the inclination of wheels when seen from the top view. If you can see my video, you'll see my two hands parallel to each other. But if let's say if you make the wheels in such a way while going in a straight line, if they both are pointing towards each other, it's called a toe in, which is in the center image of my screen. On the other hand, if they both are pointing away from each other while going forward, in that case, we call it a toe out, right? And basically, why this toe in and toe out, right? Why this is called a toe in and toe out? So you, for you to understand, for you to remember this, I would recommend just stand up and look at your feet. Okay, look at your feet and just try to point your thumbs away from each other. That would be toe out, and point your thumbs towards each other. That will be your toe in. So that is the two conditions we get in a suspension, or we could call this as a steering suspension geometry of a wheel, which is called toe, right? And for people who are wondering, there might be people who are wondering what happens when both the wheels are turned in one direction, right? They're now being turned either in opposite direction, inwards or outward. Or what happens when they're turned in the same direction? So when they're turned in the same direction, they're actually the vehicle is actually turning, and that's when you turn the steering, right? It's not going in a straight direction. So this toe condition, toe in, toe out, or no toe, is considered when the steering wheel is kept straight and the vehicle is, going in a straight direction, right? Now, this might feel slightly counterintuitive that why we need toe in or toe out, right? We could easily go with no toe, and that's where we would get the most highest efficiency of a car, right? So I would like to ask you guys, why do you think why do you think engineers not decide to go with no toe condition? Like, why don't they go with no toe condition? Why do you have to keep with toe in or toe out condition? So anybody would like to answer this? Why don't we have no toe condition in a vehicle? Ayush, Shubham, and other Ayush as well. Anybody else who could tell me why there is no toe? Why no toe condition is not favorable?
Yeah, so in the normal driving conditions, we do not need a toe in, toe out condition because our cars are usually, designed to just for commuting. But they need
Mm-hmm.
high speed cornering and they need a straight line speed where they don't want a too much sensitive steering where their car will jitter too much. So
Mm-hmm.
that's something that helps them reduce the lap timing with the toe in, toe out conditions.
Correct. So that is for Formula One, right? You're talking about Formula One, right? What I'm saying is I'm telling you that even in your commercial cars, even if you have your car at home, passenger vehicles, the no toe condition is not available in that, right? Even those cars have some kind of toe in or toe out, depending on what type of car you have. So why we don't go with no toe condition?
Arbaz, may
Just
I?
take wild guesses. Sure, ma'am.
I don't know. I mean, it might be very lame to say that, but probably because we need alignment because we don't have only straight roads, right? There are always turns and corners wherever we go in any part of the country. So
Mm-hmm, mm-hmm.
probably for balancing out, so that heads in your turning mechanism, right?
Correct.
Just
Correct.
thinking out aloud. I'm sorry.
Yeah. So, see, students, I think you should take inspiration from Jagtav ma'am, who, not being from a technical background, has taken, has shown the bravery to think out loud and to say what they're thinking. The thing is, uh, we cannot, like, as humans, we cannot be 100% accurate, right? So, when you decide to have no toe condition, you have to have 0 degree angle at your wheels, right? But as humans, you cannot have 0 degree angles at both wheels. You cannot keep both of them parallel, right? So either they are going to be toe in or toe out, any which ways, right? So for that, what we do is we intentionally keep it in inside the into in actually the toe in condition or toe out condition. So that's what led us to start with experimenting in toe out and toe in, and now we see the advantages of toe in and toe out, right? And with that, like, that's the reason why we go with why we don't go with no toe condition, right? Next, I would like to talk about what happens in turning of a vehicle, right? So anybody who's familiar with Ackermann steering geometry before we move forward? Any student who's familiar with Ackermann steering geometry?
Yes, sir. Yes.
Yes. Please elaborate. What do you know about Ackermann steering geometry?
So, like the
Yes, sir.
front front tire like takes the smallest
Sir,
space.
in
In that way, sir.
Yeah. So what happens in Ackermann steering geometry exactly?
It's like when turning the inner wheels turn more than outer wheels. That is Ackermann
so
steering.
shall I?
Correct. Shubham, let's give opportunity to students from Shanath Chandra College of Engineering, because I'm damn sure that you and Ayush both know about Ackermann steering geometry as you've completed one of our courses. So Yes, so we actually gave a good answer that in Ackermann steering geometry, the inner wheel has more turning angle than the outer wheel. Okay, so if I have to draw out the Ackermann steering geometry, okay, what it exactly looks like. So I'll just draw it on a blank screen over here, right? So let me just turn on the pen. Yeah. So let's say if you have your vehicle, I'll just draw it sort of a boxy thing when you look at from the top, right? And let's say it has four wheels. Okay, it has four wheels looking something like this. All right. And now it has four wheels. And now when you're going to take a turn, let's say it's going to take a left turn. It's going to go on the left. And this is the front side and this is the rear side. Now it's going to take a turn. In this case, what happens is we want the wheels to be turned towards the left direction. Correct? We want the vehicle to be turning in the left. That's why we want the the wheels also to be turned in the left direction. Now, our vehicle would look something like this in that case, right? We'll have the box, we'll have the wheels, rear wheels would still point straight and parallel to each other, whereas the front wheels would be turning something like this, right? And what happens with Ackermann geometry, Ackermann steering geometry, is we try to come up with a point which we call instantaneous center. Okay, now basically what that means is if you extend, if you draw a perpendicular line from the wheel, from the center of the wheel, right, it would extend something like this over here. And if you draw a perpendicular line from the wheel axis over here, from the center of the wheel, it would extend something like this, right? And these two points, these two lines would meet at a point which will coincide the line of your rear axle. Okay, it would coincide with the line of your rear axle, somewhere something like this, right? And this point is actually called instantaneous center, IC. Okay, now this IC is a point around which the entire vehicle rotates, right? So imagine if you're taking a turn, you're basically turning your vehicle in a circle, okay, which is traced around one center point, right? And that center point is IC. Okay, so for that to happen, your inner wheel needs to turn higher angle, right? So if I measure, let me just change the color of the pen a little bit. Let's take yellow. So if I measure the angle from the vertical, if I draw a vertical around here, and if I measure this angle, and if I measure this angle, right, this angle, let's call it A, will be greater than this angle, let's call it B. Okay, because it is the inner wheel. Okay, this red left wheel is the inner wheel. Since you're taking a left turn, your left wheel becomes the inner wheel, and that inner wheel has a larger angle than your outer wheel. Okay, this is what happens in Ackermann geometry, just so that we can get this instantaneous center. Okay, now just so that we can get this instantaneous center. Now, what happens when you don't get an instantaneous center, right? In that case, you won't get perfect rolling, won't get perfect steering. Okay, so what I need you guys to understand in this is, for a perfect steering to happen, we need to have Ackermann steering geometry or anti-Ackermann steering geometry. Because some of you might be thinking that in F1 we have anti-Ackermann steering geometry, but that's a little bit advanced part. But let's stick to the Ackermann steering geometry for now. In Ackermann steering geometry, when a vehicle turns, okay, when the turn is initiated, when the turn starts, your inner wheel is your dominant wheel. Okay, your inner wheel is your dominant wheel, and it is what will initiate the turn. It is what will start the turn. Okay, inner wheel will start the turn. So let's say if the inner wheel is pointed towards the left direction, that wheel will turn the vehicle in the left direction. Okay, and if you have your if you want to turn right, in that case your right wheel becomes your inner wheel, right? If you want to turn right, your right wheel becomes your inner wheel. In that case, your right wheel will be dominant. Okay, so till now I've talked about Ackermann geometry. I've talked about the dominant wheel while turning, which will be the inner wheel. I've talked about what Ackermann geometry means, which comes out to be the angle of your inner wheel versus the angle of your outer wheel. Angle of inner wheel will be always greater than the angle of the outer wheel, right? So till now, is there any doubt from anyone, okay, regarding the Ackermann geometry, regarding why we get these two different angles and why left and right wheels are inner wheel in their respective conditions? So any doubt for anyone, please let me know. Okay, if there are no doubts, I guess I can clear out the screen and start out with the next thing that I want to talk about. All right. So I guess we have a shy audience from the college that we are associated today. Anybody who has any doubt, please let me know. Please ask me. Feel free to ask stupid questions. We are all here to learn. Even if you ask the stupidest of all the questions, I'll be happy to answer it. And you might learn something new out of it, and we all might learn something new out of it. So please just unmute yourself. If you have any kind of doubt, any kind of problem or anything that you didn't understand, please ask the questions, and I'll be happy to answer them. Okay, so moving on, what exactly happens in your exactly happens with your toe when you have an Ackermann steering geometry, right? So what we talked about in Ackermann steering geometry is when the turn has taken place, the inner wheel becomes the dominant wheel, right? The inner wheel becomes the dominant wheel. Now you can imagine this by you can imagine two conditions for it, right? So let's say first we have a vehicle which has a toe-in condition. So this is how the wheels would look. Of course, this is very extreme. The wheels are not turned more than 1 or 2 degree. This depiction is very extreme, and it's for your understanding. Now this is the toe-in condition. Okay, so let's say we have a toe-in condition, and we want to turn the wheel. Okay, so in this case, what will happen is when you turn your steering wheel. Okay, when you turn your steering wheel, this wheel will turn towards this direction. Okay, let's say we are trying to turn the vehicle in the left direction. This wheel will turn towards the left. This wheel will also turn towards the left. And if I measure the angle of my left wheel and angle of the right wheel, right, with the vertical, okay, with the vertical, at some point, okay, at some point of turning, my inner wheel will have 0 degree angle with the vertical, correct? Because I'm turning left and it's already turned right. If you think about this wheel, if you just talk about this wheel when it's in toe-in condition, right? I'll just zoom it in and I'll draw the vertical line with, let's say, a black line, something like this, right? And let's say if you want to turn this wheel in this direction, now you're turning this wheel like this, right? Towards your left, towards if you turn your steering wheel towards the left, now this wheel will turn towards the left direction, and at some point it will meet the center line of your wheel will meet the center line of the vertical axis, and the angle between them will become 0, right? So now in this case, at that point, what will happen to the right wheel? Because they are all rigidly connected to the steering mechanism, which would look something like this. They're all rigidly connected to the steering mechanism. As this wheel is rotated, this wheel will also rotate in the left direction. At some point where this angle, let's call it angle A, right? Sort of looks like angle D anyways. So let's call it angle A, and let's call this angle as angle B. At some point, angle A will become 0. And at that point, angle AB will be greater than 0. Because any which ways, it's already having some angle with the vertical. And when you turn your steering wheel, this angle increases. Okay. So the B will always be greater than 0, but A at some point will become 0. Okay. At this point, what do you think will happen to the vehicle? Will the vehicle move forward or will the vehicle take a turn?
It should move forward
Why so?
because one side wheel is straight and one side is like turned a little. So I think it will move forward only.
Okay. Okay. Now, with that logic in mind, okay, put a pin in that thought and let's keep it in mind for a while. With that logic in mind, let's look at the toe out condition. Okay, so we have the toe out condition where we'll have the wheel pointing outward like this, right? And let's say we are taking the left turn once again. We are turning the wheel in the left direction once again. We'll have our verticals something like this, right? Vertical line something like this. And we'll have the angle with the vertical over here and over here, right? So in this case, if you're turning left, now this is your angle A, this is your angle B. In this case, angle A, when angle A was 0, angle B was greater than 0. In this case, angle A will always be greater than 0. And at some point, angle B will be equal to 0 because it's moving towards the vertical line, correct? Okay. At some point, angle B will be 0 and angle A will be greater than 0. And in condition, it will be opposite where angle A is 0. At the point where angle A is 0, B will be greater than 0. Okay, so you guys say that the vehicle will move forward because one of the wheel is pointing forward, right? What will happen in this condition? What will happen when angle B is equal to 0 but A is greater than 0? What do you think will happen?
Same thing.
Same thing. Will it move forward?
Yes, sir.
Okay. So here is where I thought you guys might have a doubt in the previous slide that I taught, because like I said, while you're taking a turn, when you're initiating a turn, your inner wheel is your dominant wheel. Okay. So in case of toe in condition, which is on the top over here, right? In case of toe in condition, when angle A is 0, right? Since you're taking a left turn, your left wheel becomes your inner wheel, correct? Since you're taking a left turn, your left wheel is your inner wheel is your dominant wheel. And since your dominant wheel is pointing straight, which means it has the angle 0, your vehicle would move in a straight direction. Okay. On the other hand, when we talk about toe out condition, which is down here, your left wheel is your dominant wheel, you're taking a left turn, and your left wheel, your dominant wheel, has an angle greater than 0, which means the vehicle will follow this wheel and it will turn left. Okay. So in toe in condition, when you turn the steering slightly, nothing happens, your vehicle will still move forward, go straight. But in case of toe out condition, when you slightly move your steering wheel, your vehicle will turn quickly. It will turn towards the direction of the vehicle, right? And this is where the sensitivity of the steering comes in. This is where the straight line stability comes in. Okay. So what do we understand by this? When you have toe in, right? When you have toe in and you're turning your steering wheel, right? Your vehicle will go straight for a specific amount of turn of your steering wheel. But then if you turn it more, then it will start the steering or start the turning of the vehicle. But in case of toe out, every slight movement of your steering wheel would result in a turn. Correct? Is this statement true, everybody? Is it clear to everybody?
Sir, I had a doubt.
Sure, tell me.
In sir toe out condition, like when we are turning in, like say in the left side, the right side wheel, that outer side wheel will be straight, right? So if the vehicle turns, won't it be veered out?
It will be veered out. That's the thing, right? So your inner wheel is your dominant wheel. It'll pull the right wheel and it'll slide it a little bit unless you complete the turn. Unless you rotate your steering wheel more.
Okay.
Yeah. So what we have seen in the last slide, that inner wheel is your dominant wheel. So we'll be following throughout this, at least for this bootcamp, we'll be following the inner wheel. What happens with the inner wheel, right? So now what was happening with the inner wheel? We were getting a in case of toe in condition, right? In case of toe in condition, even after getting small disturbance or small turns in your steering, the vehicle was going straight, right? But in case of your toe out condition, even a slight turn was resulting in a turning, right? It wasn't going straight. Okay, not straight. So what we can determine from this is, if you have toe in condition in your vehicle, right, it will be better to go in a straight direction. If you have toe out condition, it will be better for turning. Okay, because your steering system becomes a lot sensitive when you have a toe out system. Okay, so now imagine you're trying to make a sports car. Okay, and you're making it for a track like Bahrain, okay, where you have a lot of straights and there are very little turns, right? So in that case, you will be inclined towards making a toe in condition. You'll be inclined towards making a toe in geometry for your steering suspension, because in that case you're getting straight line stability. Okay, so even if there's some disturbance from the road, right, even if there's some disturbance from the road which results in turning of your wheel, right, in that case, even in that case, your vehicle will keep going straight. Okay, but for a track like Monaco, where you have a lot of turns and a lot of sharp turns rather, in that case you would require very, very sensitive steering, because you'll have to go from left to right within a fraction of a second, right? And that is where you would keep your toe condition to be toe out. Okay, and that is what happens in Formula One, right? So for straight lines, usually people keep it toe in to get the straight line stability, and to get cornering stability, what we call it, cornering stability or highly sensitive steering, we keep toe out condition. Is that clear to everybody?
Yes, sir.
Okay, could someone explain to me why do we need toe out condition for cornering stability? Okay, anybody who explains this to me will get a chocolate. So I guess that's an incentive. Yes, Ayush, you were saying something.
Okay, sir. It's about to explain, sir. Uh, so while taking a turn, like the inner wheel in the toe out condition, the inner wheel will be dominating. So
Mm-hmm.
the vehicle will be stabilized in the toe out condition while taking the turns. And if
Mm-hmm.
it's in a toe in position, then the straight line path will be more stable.
Correct. So when there is a toe-in condition, even if you get small nooks or small deflections in your wheel. Now imagine your vehicle is going straight, right, and it has a toe-in condition. I don't know if you can see my hands, but let's say this way, right? So you're seeing my hands from the top view, right, and the vehicle is moving forward. Okay, since you're seeing it from the top view, you will see it to be going on the top of the screen, right? So now since it's moving forward, let's say there is a small disturbance, right, which pushes the wheel like this or like this in any of the direction. Right. So let's say this pushes the wheel like this. Now, in this case, my right hand, this hand, is pointing straight towards the front, right, and my left wheel or left hand is pointing towards the right, right. But in this case, since we know that the inner wheel is going to be the dominant wheel, we can be sure, since the dominant wheel is pointing straight, the vehicle will keep going straight, and this turn wheel will wear a little bit. Okay, and like I said, the angle is very very little. This is also an exaggerated view. The angle is, if this is the straight, the angle looks something like this. It's not even 1 degree. It's very very less. Okay, it's either like one less than 1.5 degree, if I'm being very honest. So because of that, if you have a toe in condition, you get a straight line stability, which means your vehicle can go on a straight roads much faster, right, and much easier. Okay, so how faster? Because if it's going faster, and imagine you have a fast car and there's this very very small rock or stone which comes under your tire will deflect a little bit. Okay, your tires will deflect a little bit, and that will push your steering, push your wheel in one direction, right? And because of that, if you have, let's say, a toe out condition, your steering would be very sensitive, and if a slight turn occurs, your vehicle will turn in one direction. Okay, but if you want to go in a straight line, in that case, if you have a high speed, you can keep your toe in condition, and even if there's a huge or a slight deflection in the tire, your vehicle will still keep moving forward. Okay, and that's the logic behind toe in and toe out condition. So Biswa has said that toe in is used for straight line stability and toe out is used for cornering or turning stability. Absolutely right. So like I said, if you want to go for a condition where you have a track like Monaco, where you have a lot of turns and you have to, turn quickly from left to right, in that case, you would require a very, very sensitive steering, and that's where you would keep your geometry as toe out. But a track like Bahrain or Australia or many others, in that case where you require high speeds or speeds where the track is very very straight, right? You have very straight, very long straight patches. In that case, you would go with a toe in condition. Okay, until now, and even now for that matter, people go with either one of these two. Okay, so either they keep toe in condition or they keep toe out condition before the race starts, right, before the practice matches starts. So let's say if you were the race engineer, head race engineer of Mercedes, Ferrari, or whatever team you're working for in Formula One, and you have to decide if the vehicle's toe angle is to be kept toe in or toe out. This is the criteria you go with. Okay, this is the criteria you go with. You see what exactly the track type is, and then you select toe in or toe out condition. Okay, now what did the Mercedes team do? Okay, so as I said in the beginning of the session, what they did was they created a mechanism through which they can dynamically switch between toe in and toe out. Okay, let me repeat myself. They created a mechanism using which they can dynamically change from toe out toe in condition to toe out condition. What do I mean dynamically? While the race is going on, while the driver is driving the vehicle, in that case, they created a mechanism which can be incorporated to, go from toe in condition to toe out condition. Okay, and what do you think, apart from heating and apart from a tire warming up, which someone talked about before we started the session, what do you think is the advantage, from the point of view of what we have studied in the steering system in this boot camp? what do you think is the advantage of having this kind of system which can incorporate both toe in and toe out condition?
Like when the formula
It's
car is in
favorable for,
straight line,
yeah.
Yeah, please go ahead, Suvika.
when the formula car is in straight line, they can switch to toe in condition, and that will make it stable. And while the more turns are coming, they can switch to the toe out condition.
Correct. So, like Suvika said, what will happen? So, what they will do usually to get more out of the vehicle, right? So, like I said, everything depends on the speed, right? In Formula One vehicle, all you need is speed, or you need to go faster and faster for a specific piece of track, right? So now what they did is whenever there was a straight patch, Lewis Hamilton would simply pull his steering wheel up, and the toe condition would change to toe in, and that would give him the straight line stability. Now, like I said, if you get straight line stability, right, whenever you get high speed, whenever you go into a high speed, this thing, whenever you achieve a high speed and there's a bump or there's a nook or there's something that deflects your wheel, you get uh, you always get your vehicle going in a straight line. That's what the straight line stability means, right? So if you have toe in condition, you can go much faster on the straights, right? But if you have toe out condition, you have to be a little bit careful before increasing the speed, because even a slight deflection in your wheel's turn would result in turning of your vehicle, right? Now, in case of turning, so whenever the straight patches are over, what would Lewis Hamilton do is he would push the steering wheel uh, down or towards the forward direction, and that would result the toe to go outward. Okay, it would result the toe to be out, right? And because of that, he would get cornering stability. His steering system would become more sensitive. Okay, so that even a small deflection which he does with his hand would result in a quick turn, right? And the vehicle would turn easily. And that is what gave Mercedes an unfair advantage over the other vehicles, since they incorporated both toe in and toe out condition in their vehicle. Okay. Apart from that, okay, what was the second advantage of that was they also got heating of the tires. So usually when the Formula cars are designed, they are kept in negative camber. Okay, so if you're seeing the car from the front, any photo that you see of a Formula car from the front, you will see that the wheels are tilted this way. Okay, they are tilted this way. So that is actually to incorporate the lateral load transfer, which I guess we cannot go in depths of that in this session. But what happens is when you're turning, your load is shifted to one side, right? So this is what you feel in a car. If you're taking a left turn, you automatically move towards the right, right? We call it the centrifugal force, right? And same thing happens with your Formula vehicle or any kind of vehicle. And this, if you keep your negative camber when you're seeing from the front, right? Let's say if the vehicle is moving towards turning left, it will move towards the right, and this would result in the negative camber to become straight, right? And since most of the load is on the outer wheel, it will get the maximum contact patch, and that is why you keep the negative camber. Now, because of this, what happens is when you keep a negative camber, your inner part of the tire is in more contact, or for the most of the time, it's in contact with the road, and that it gets heated up really quickly, right? But the outer part is cooler. It's when compared to the inner part, it is cooler, right? The temperature is lesser, and because of this, there is a change of grip in the tire. Okay, so every time you take your vehicle out, or anytime you go for a Formula One race or you see a Formula One race, they expect, or they want the tire to be heated up. Okay, because the heated up tire would stick to the surface of the road much better, and it would give a high amount of grip. Okay, so in this case, since they have this negative camber, the inner part of the wheel is heating up, it has good grip. The outer part of the wheel is not heating up, it does not have a good grip, right? So when they change the toe of the vehicle, right, when they change the toe of the vehicle, somehow because of how the mechanisms are made, how the mechanisms are packaged, when they change the toe of it, the camber also changes slightly. So from this, it goes to something like this, and this leads to the heating of outer part of the wheel as well, not just the inner part, but the outer part of the wheel as well. And this is how they can make sure that they can be they get another advantage, where their entire wheel is heated up, entire tire is heated up, and they can get the same amount of friction or same amount of grip on the entire tire patch on the road. Okay, and that was the advantage that they got in the uh, Mercedes DS system. Okay, so is there a doubt, anybody, how the Mercedes DS system worked, or what was the purpose of it and what were the advantages of it? Anybody, if you have any kind of doubt, I can understand you might not be from the vehicle dynamics domain, you might not understand the terms that I'm speaking. So if there is any kind of doubt, how no matter how basic it is, please ask me and I'll be happy to answer it. Okay, Biswa has asked that in Ackermann steering geometry, toe in is for straight line stability, toe out is for cornering stability, and is it reversed for anti-Ackermann geometry? So see, it does not matter what geometry you have in your steering wheel, right, in your steering mechanism, because these geometries are what you have for your turning, in case of your turning. But when you're going in a straight line, or when you're initiating a turn, everything boils down to your dominating wheel, which always will be your inner wheel when you're initiating your turn, right? So because of that, even in anti-Ackermann geometry, the same condition applies. So even in anti-Ackermann geometry, your toe in will be your straight line stability and your toe out will be your cornering stability. So is that clear, Biswa, first of all? Okay, anybody else has a doubt, please go ahead and ask me. Please unmute yourself. I'd be happy to answer it. And you can also post your doubts in the chat box like Biswa has done. Okay, is there anybody in this batch of bootcamp who would like to tell me what would happen if you have a toe out condition and you're going at a high speed on a straight line?
Sir, that's bit like if you're going at a high speed, no, like if a slight deflection in the steering, it will take the turn. So the vehicle is like highly unstable at that position.
Right. Then for the vehicle to go in a straight line, it will be highly unstable. Okay, Biswa is also asking another doubt: is uniform heating in F1 done by both negative camber and toe in? Okay, so Biswa, the uniform heating is, I would say that never done in F1. Always the inner part of the wheels are slightly at a higher temperature, right? But because Mercedes is incorporating DS system, because of that, some part of the outer wheel gets heated up, and it leads to a little bit better grip or better temperature distribution. So it's never uniform, but the distribution becomes a little bit better. And it is not done by negative camber, it's a result of negative camber. Negative camber is used for something else, but because we are using negative camber, the the heating of tire takes place in this way. Okay, so before we conclude on this session, I would like to tell you that we are offering free courses to anyone who would like to learn something new, who would like to upskill themselves. And all you have to do is fill up the form that I've pasted in the chat box. And after you fill up the form, in the form itself, we have asked you what is your field of interest, and based on that field of interest, you would be enrolled in a free course. So if you're interested in learning vehicle dynamics, if you're interested in learning design, you could go with that, and we'll offer you a free course which will be of, I guess, of 5 to 6 hours, which will give you a basic understanding of these things and boost your curiosity. So go ahead, everybody. I would recommend you to go ahead and fill up this form to kickstart your upskilling journey and to learn something practical. Saket here is asking, sir, because but due to lateral load transfer load on the outer wheel is more than the inner wheel, so traction load on the outer wheel will be more. So isn't the outer wheel more dominant wheel? Definitely, Saket. When the turn is completed or when the turn is started, right? In that case, the outer wheel becomes dominating wheel. But when you're starting the turn, right, when the vehicle is going in a straight direction and you just initiated the turn, in that case, your inner wheel is the more dominant wheel. And Biswa is asking, uneven heating leads to uneven expansion. As a result, there is an uneven gripping. That is why DS system provides to make a little bit even gripping. Yeah. So see, any which ways, if there is uneven heating, there is going to be uneven gripping of the tires, right? And if you can make the distribution go a little bit smoother, like temperature distribution go a little bit smoother, the grip that you would get out of the tire would be more, I would say, uniform, and because of that you would get a better grip. So yes, the answer to your question is yes, that you're right. Because of uneven heating, you get uneven grip, and when you make the heating slightly even, not the most even or most perfect type of uniform distribution, but it will be slightly even. In that case, the grip that you'll get off the tire will be a little bit better. Okay, so I guess that solves your doubt, Saket and Biswa. If there's any doubt, you can ask it again, chat box, or you can unmute yourself as well. And that goes for everybody who's attending the session. If you have any kind of doubt, please let me know. Okay, I guess we are at a point where we can conclude the session. So before I conclude, I would like to thank the uh, the organizing members of this boot camp from the Sharat Chandra College of Engineering and Technology. Also, Ms. Priya Jagtap, Dr. Priya Jagtap, ma'am, who has taken this initiative to collaborate with ETG for this boot camp. And I would also like to thank every participant of this boot camp to coming over here and listening for me for 1 hour. And I hope you learned something new. I hope you would like to explore more, and I hope you have gotten a spark of your curiosity built into yourself after this session. And with that, I would like to conclude my session. So keep learning and keep exploring, everybody. And before we conclude, I would again request Ms. Priya Jagtap ma'am, Dr. Priya Jagtap ma'am, to say a few words in conclusion of this session.
Thank you, Arbaz. It's been a wonderfully insightful session, I must say. So I enjoyed learning about 0 degree angle, straight line stability, and now I am going to look at vehicles from a different perspective, and I'll probably go back and watch 1 or 2 Monaco, Bahrain stints, so that now I have more insight and a newer perspective. It's really been wonderful listening to you, Arbaz. And on behalf of our institution and on behalf of the students, I heartfully thank you for conducting this boot camp for us. And it's been really educating. Thank you so much.
Thank you, ma'am. Thank you.
Thank you.
Thank you, ma'am, and thank you, everybody. And ma'am has brought up a good thing. What you guys can try out is, watch, if you like to watch races, go back and watch Bahrain races, go back and watch Monaco races, and you might spot these differences in the vehicles, and that would be, confirmation to what you've learned today. And you can also, if you want, you can also spot different things in these kind of events, and you can analyze why these things are different. So once again, thank you, everybody, and thank you, ma'am, and thank you, the institution of the College of Engineering and Technology. And I thank everybody for attending, and I hope to see you in the next boot camp, which I will be conducting on how to crack your interview. And till then, I hope everybody, I wish everybody to keep learning and keep exploring. Thank you.
Thank you, sir.